Welcome back, everyone, to another HyperSDK Developer Call. Nice to see a lot of people returning and then also some new faces. This week, we're going to go over Vryx progress and where that stands, go over a more detailed overview of the ProgramVM, and also have a ZK demo of something that someone was working on in the community. So we'll start with the Vryx update from Patrick.
All right, yeah. So we're making pretty good progress on getting Vryx in a place that is testable. So all this is open PRs, by the way, so you could definitely follow along if you want to. But first thing, we got a domain for Vryx, so that was a big step in the right direction. But outside of that, this PR here, which I'll share, I think it's PR 711 if you want to check it out. Vryx obviously has a lot of moving parts. Funny enough, in aggregate, I believe it's simpler than what the HyperSDK was pre-Vryx. However, it is more or less a deep rewrite of many core components of what's going on here. So the POC is getting most of the functionality in a good place just to test its capability in this DSMR construction. So the decoupled state machine replication construction. No tests, very minimal, just about testing the core ideas that I wrote up in the Vryx document. So if you're curious, what some of those core ideas look like and how shitty of Golang code you can write and still get it to compile, this is a great PR to look at. But the part that brings it all together was that this POC, I mostly finished the code for it, a very alpha of alphas, Friday morning. And then transitioned to the DevNet testing phase, which is where most of the rubber hits the road. And so that is being tracked in this PR called DevNet Deploy. In DevNet Deploy, the main goal is to create a single script that anyone can run if they have an AWS account and reproduce all the results. So that's what this deploy devnet.sh does. And want to give a huge shout out to the Avalanche CLI team who makes this super easy. I can spin up a entire HyperSDK Vryx devnet in what is 120 lines of bash or something, where 80% of that is made up by configuration files. So the point here is that you'll be able to just click a button and spin up a whole cluster across any number of regions and machine types. And then the part that I'm adding here is a feature that got merged late last night on the Avalanche CLI, which allows you to have external load testing. So you can write a load testing script, which you already have in the HyperSDK. So I have to modify it a bit. It will deploy that to some machine in the cloud, which has much better bandwidth than my local machine, and then we'll drive traffic. Now, the way that I've set this up to be as realistic as possible is it's all traffic is first sent to API nodes before validators. So I've seen a lot of different load tests where you just pretend you can somehow hook up right to the validators and that's how things work in a real network, which is not the case. So this tries to mirror as close as possible to what actually a production setup could look like. So so I started playing around with that, getting that good to go. Again, not the best Golang, but trying to get it just to work at this point. Went down a 2-day rabbit hole that I found out under load, when you push above 70,000 TPS, or you're trying to from your local machine, at least on a Mac OS, something's wrong with the networking card and it causes WebSocket connection corruption. So I thought there was a bug in either Gorilla WebSocket or the HyperSDK or Avalanche Go and how it handles WebSockets. Nope, switched right to AWS, tested the same thing, no bugs or errors whatsoever. So I believe just don't load test on your Mac OS or on Comcast. I don't know what one of the two it is that causes problems, but nonetheless, the AWS thing will be the dedicated path forward. Yep, no.
Yeah. Just a quick question on this. Trying to make sure I keep notes. One of the developers on my team uses a Mac. What kind of Mac do you have? We'll probably have them test on AWS as well. Just want to make sure. Is it the M3? I'm wondering if it's an issue with the M3 chips or something, the new Macs.
I don't know. I think it's just that
Just Mac?
I think, yeah, just a Mac with the M series chips.
Got it.
I think
Thank you.
like, I mean, I think like the realistic case here is like most of these, like, I don't know how much time Apple has spent testing like Mac networking when you pump like 30 megabytes up. Like, I just don't think that that's one of their like primary test cases. So I just don't think that they've spent a lot of time playing around with that. And so all I would say is like when you're pushing this level of throughput, sometimes things go wrong in areas that are unrelated to what you think you're working on, and you have to sometimes debug those things, and sometimes it's frustrating. So that was a big distraction, but we're on the right path again now that we've just migrated to just a full Linux stack for testing this stuff, and we'll see if you have any other issues. But yeah, so you can follow along here. But what will happen is that in the next few days, I expect to have a full script, on some average code at best that you can just run one command and it will spin up an entire cluster and then send hopefully over 100,000 TPS to it sustained. So some of the other cool tweaks that were needed to get to this point, one of which was I actually ended up having to write this thing I'd been working on thinking about writing for some time called the FileDB. So to add pruning of block data, chunk data, and stuff, I would just as a naive solution was originally using like Pebble. Turns out with Pebble, which I had read somewhere but hadn't actually benchmarked and tested myself, you can't do concurrent writes with Pebble because of the way the LSM tree works. And so if you want to like store a bunch of chunks at the same time, for example, like it ends up getting bottlenecked on Pebble. So FileDB is really what it sounds like, is this like lightweight way to like write data, checksum it and fsync it to disk if it's addressable. And then it's very easy to prune stuff because you can just remove it. No compaction, no overhead, super fast. I think it was like 4 to 10x faster than Pebble with my testing. But this is what we use now for block storage, chunk storage. So the only thing that uses Pebble now is the state access using MerkleDB. So if you want to take a look at this too, this is interesting. But this was all the things that I was doing just to get to the point of having like a viable POC that had steady state disk usage. Because if you run I think I mentioned this before, but if you run like a throughput test at 100,000 TPS, like after an hour, like you're going to be using terabytes of disk if you don't clean up after yourself. And so this cleans up after itself now fully. So the only thing that grows is the state size if there's more accounts. But if the accounts stay the same size, the state size doesn't grow, which is pretty cool. So yeah, so this is what I've been working on. It's not nearly complete yet, but it is progress. And so in the preliminary tests, when I wasn't having the WebSocket issues, I was able to get it up to, I think, something definitely over 50K TPS, and that was on a smaller machine. The bottleneck, just to report, is none of the things that it used to be, which is awesome. So the bottleneck now is purely authentication. So like signature verification. And the way that the HyperSDK execution pipeline is set up now is that none of this, so actually one more chart I wanted to bring up here. I'm just going to post this here. And then let's see. There we go. All right. So most important result is this. You may say like, what is this graph, or like what's going on here with these like chits and everything like that. So the consensus engine on Avalanche Go, this is basically the sum of all the time that the consensus engine is taking. Now, when you push, let's say, the subnet EVM to the limit, what will start to happen is that the verify of the block will start to take longer and longer and longer, or the accept will take longer and longer and longer. So you may have a couple hundred milliseconds or maybe even a second And what happens is that in the consensus engine, when you trigger some sort of action, like let's say I hear about a block for the first time, like someone push queries me or someone put gossips me, or I pull query a new block, what will happen is then that the engine will pause while you try to verify the block. Well, in the HyperSDK with Vryx, the verification now happens fully after acceptance in this like async execution thread where you have tunable cores for signature verification and tunable cores for execution and tunable cores for the state commit part. So none of the expensive and like heavyweight stuff happens in the consensus loop at all. So every second at speed like this, the amount of time currently being spent on consensus operations is like 30 milliseconds total. Now, in the past, like HyperSDK currently, this is, I think, like 900 milliseconds out of 1 second. So this is a massive improvement for like the stability of the consensus operations, which no longer require like heavy verification during the actual block processing step. And that verification is now after consensus, which is a massive like DOS reduction, like DOS vector reduction, as well as just like everything's more stable. And so this was like the huge first result that I was excited to get to, which is to say like moving all this stuff out of consensus makes consensus more stable. Success. And so then the part that gets interesting from there is, well, your bottleneck now becomes either one of two things. One, like how quick can you distribute chunks of transactions to other members of the network? And then two, how quick is your execution loop? The distributing chunks to other people hasn't been a bottleneck at all. We use like, not only is like their ample bandwidth on the modern cloud, but also like we use the standard compression on the network layer between nodes. So that also has been shown to be pretty effective in these tests. The issue is in the execution loop, the number of cores required for signature verification. So when you're processing like over 100,000 TPS, like even if you use all your cores across like a machine, let's say you have a machine with like 40 cores, it can still take like 400 or 500 milliseconds just to verify the signatures, ED signatures. And so the next test is seeing if I can go above the 100 goal by just continue to increase those cores. Now, the goal is obviously to make it more efficient, but it's really nice to know that if you can just scale things up by adding more cores, that we are doing something right, which is a good sign. In the past, that was not the case, and was what prompted all the Vryx stuff, because the block distribution part became the bottleneck. So that's no longer the bottleneck either, and the problem is just how many cores do you have to verify signatures. So long story short, I'm liking where we're at. I like where it seems like we're going. We just have a little bit more work to do to get this to a point where we're happy with the where we can actually start to have this like replicatable script that anyone can use.
Patrick,
Yeah,
could
you can see my journey with trying to figure out this WebSocket issue where there was all this message compression or corruption. Sorry.
Patrick, could you touch a little bit on like what results you were seeing with like certain hardware setups?
I didn't push any of them to the max yet, so I don't want to say any results yet. So like I think once we have the results set up, we'll be good to go. I think the actual like framework setup will be good to go. Because the problem is like when I was trying to push load, like the connections were destroying and reconnecting every 10 seconds or less. So like it was unclear what was actually going on and like what the actual success rate of transactions was. So once we have everything hooked up on AWS, it should be much clearer. But like I said, you'll be able to configure all this when you run your own test. So the important configurations are really these guys and this node type. So I was running the test on C5 9x large, but I think we'll probably run it on Gravitons on AWS because they're about half the price. And I think that actually should be faster because of some of like the ASIC stuff they do with networking on those Gravitons. But then you can determine how many APIs and validators you want across how many regions, and then all the load testing and everything will just like automatically ingest that and take care of it. So if you wanted to, let's say, replicate certain scenarios and see what like sort of traffic you can push, you'll be able to do that with this load test. So if you wanted to pay to run up, 1,000 validators to see what happens, and I'm not sure that that'll work at this stage, but you can if you want to. I think our goal for the DevNet will be something like 50 nodes or something like that to start. So that's what we're trying to get to. This test is just on 4 validators and 2 APIs. So, but you got to start somewhere.
Sweet. Does anyone have any questions about the Vryx update?
I have a question. So the fact that the networking is becoming really not the bottleneck anymore is making me wonder about the signature verification, how it can kind of be sped up. I know that on like the FireDancer side for Solana, they ran into a similar thing. I'm just hoping somebody ends up building it out at some point. It might be my team at NodeKit, or it might be somebody else, but trying to experiment with kind of FPGAs and other weird ways of doing the signature verification extremely fast. Probably requiring Go assembly, I think, at some point, because when you're going down very fast for Go, I think Go might end up being the bottleneck on some of it if there's so many signatures per second. So really interesting to see how fast the signature verification can get if that's the bottleneck.
So we tried to speed it up with math before. So like you can do these like batch verification style things with ED. And the problem with those is that they're really good at telling you if all the signatures are correct or at least one of them is wrong, but not which ones. And so before, when we had like enforced semantic and syntactic verification of transactions, like that was great because we could just run that check over the whole block. And if any of them failed, we knew the block was invalid. In this case, we no longer do that. At least in the POC, we assume that if like a transaction's been sequenced and has an invalid signature, that the chunk can still be valid. Now, we could change that, but the issue is that, we could change that. And if we change that assumption, then I think we could basically cut this in half. What we found was like that the batch verification on ED was about 50% of the batch verification time outside of it. Now, the thing though is like this only applies to ED signatures. So if you were using something like SecP or something like that, like you would see none of this speed up. So yeah, I think that's like what people have found to be the fastest with that, as long as you're willing to enforce in some way that all the signatures included in something are valid.
That makes sense. And you're still using BLS signatures for the chunks themselves. It's ED for individual transactions, right?
Yeah, the BLS stuff is actually pretty fast. Like every verification or so takes like a millisecond, and that's
It's
not
all
even
in assembly.
parallelizing them yet.
It's all in assembly for most of the BLS stuff. I think you guys are using BLST, if it's the same one for the
we're using
AWM
BLS.
library.
Yeah, I think
so it's all assembly.
Yeah, I mean, we're using like the ED libraries are pretty optimized too. Don't get me wrong; like it's not like we're using some slower variant of anything. I guess it's just a lot of math that the compute is doing. So, like the CPU is doing. So I think that we will look at it first. We'll just try and see if we can get it with cores. But in the case that we don't want to do that, then we'll start to do the batch verify. All the batch verify stuff I did previously, like I haven't really touched as part of this POC. So I'd have to take another look at that and adopt it for the Vryx world. So I need to think about if that's the right direction to go, but there's definitely that low-hanging fruit on this benchmark, assuming that you have ED signatures. Yeah. The other thing you can do actually, if you're just trying to test Vryx, not the compute stuff, is you can just shut off signature verification. So if you want to just test it without that and see where like the bottleneck is, assuming that signatures are verified like infinitely fast, which is what I do some of the time, that's a very useful configuration option.
Sweet. Thanks for the questions, Noah. Next, we'll throw it over to Richard to talk about the ProgramVM.
Right. Can you guys hear me all right? Cool. Give me a sec. So I don't have anything super interesting to demo just yet, but I figured I'd throw up the goals and the milestones. These are all kind of subject to change, just like anything on our roadmap. But I figured I'd break it down a little bit. And on the heels of Vryx and Patrick talking about 100K plus TPS, obviously for application development on HyperVM is meant to move fast. We don't want to slow down the VM with programs. So we're doing a lot of looking into, keys and how we can parallelize things, or if we can parallelize things, you're not stuck trying to mint NFTs just on that total supply field. But yeah, that's kind of the main goal, is to add application development kind of on top of a VM without slowing it down. Obviously want ease of use, writing, reading programs, whether you're just like developing a single application or you're building the next kind of Trader Joe or Uniswap or whatever, where you're building a program that's composed of other programs, that has a factory that's launching out liquidity pools that are other contracts or programs. And everything should kind of be like a native look and feel for any Rust developer. Yeah, that's like a big one, is that we are writing the SDK at least in Rust, and everything's being run in WebAssembly. And a big thing that we're going to target too is upgradability. We kind of want that baked into the framework, so that, maybe this is a big feature where you have some core feature to your VM and you want to make upgrades without having to fork or, coordinate upgrades amongst all the validators. Yeah, stretch goals is adding other languages. That's part of the reason we chose WASM runtime, is we don't just want Rust developers to come in. That's just where we're starting. Assembly script is like a bit of a question mark to, pick off an easier programming language to pick up, but we are definitely thinking about exploring other stuff too. Milestones, not much to talk about here. Right now, we kind of have like a simulator where you have to pass everything, all your arguments in, and it works super well, but that's not really secure. Anybody, we've got like a token example where anybody can transfer any tokens from any addresses. Obviously, we need some type of signature signed, verified transaction, or address, sender, whatever, that gets injected in the context. So working on that right now. Yeah, a big milestone will be deploying a DevNet, so that people can test out programs on an actual live network, or whether you're deploying that yourself or it's something we deploy. And again, that upgrade framework is a big one. And yeah, obviously, one big thing, like coming from the EVM world, it's not the easiest there. I don't think it's the easiest thing to go and find that big JSON blob ABI to construct your transactions, or having to always rely on a UI and something like Wallet Connect to give you transactions just to sign. So building in client support and making that as easy as possible would probably be another stretch goal there. Let's see. So yeah, I just wanted to ask some questions. Like, we're still in the design phase. So I thought I'd turn it around to you guys. I don't know how many kind of smart contract people building VMs versus people working on smart contract platforms or anything, but I threw up a couple questions, so I'll leave it to you guys. The first one here is, what do you like about smart contract frameworks that you're currently using? Do we have any smart contract devs on the call? No, nothing. Marco, I know you've written some smart contracts.
Yeah, but I would say not a full-time smart contract developer.
I mean, from my perspective, it's pretty important that we get the way of interacting with the contract smooth. So that's probably the biggest topic, because like this is how all of the, let's say, client-facing apps will be built. So if it's easy to do that, then that's the biggest step towards like bigger adoption with more apps, etc. Yeah, so maybe
So-
I'll go ahead. That's one topic, and like the other topic is like as we build this, we'll probably need to have like some kind of like standardized token formats, because this is basically a must-have so that different apps can interact and rely on stable interfaces of different token types, right? If you think about NFT marketplaces, if you think about like DEXs, they all rely on some standard ERC20 interface or ERC721 interface. Yeah, Patrick and I have been talking about that in depth, going back and forth on whether we should have some type of interface that's kind of like an ERC20, or if there should be something that's a little bit more native to the underlying VM. Patrick, I see you unmuted.
Yeah, I mean, I think that's the most consequential conversation we've had is really like the representation of value there. So I think Move like really pushed things forward and how it thinks about like value and how value moves between parts of the contract. Much more so than like maybe the traditional model where you just treat it as like a value in some sort of storage, and then like people can interact with that like state slot all over the place using some sort of ACL. I'm not sure how I feel about it yet, but like I think there's a huge opportunity to do something thoughtful here around that. That is maybe, yeah, I'm not sure how I would even describe the design pattern, but like the biggest thing is to say, how integrated should value be within this framework? I think is the big question. Because you could take this super nihilistic view, don't care about it at all, just say like we run code. And that's where we left off. And then people could build like SDKs on top of it. I think people have done the same thing with like on Solana with like Anchor and some of these other things, which I think are pretty cool. And say, hey, we're trying to make something as minimal and fast as possible. Like if you want all this stuff, like great, like build on top of this lower level framework. Just to keep the lower level framework clear, easily testable, and secure and reliable. However, the lower level framework definitely has a lot of power to push people in a certain design direction. So maybe there is a compromise between this write code, it'll run, and this more, I don't even know what the term for it is, but maybe like paternalistic view where you tried to really limit what people do or can even do with value to try and prevent entire classes of bugs. Like we've already talked about this with reentrancy, where that's disabled by default. But I think that there's obviously quite a spectrum you can run when you start to entertain those ideas. Before we go further on this conversation, which I think is a great one, I just wanted to call out just for confusion maybe. The HyperSDK programs will be a standalone module that will execute these things. And then it will be deployed in a ProgramVM example that is based on like using all this stuff. But it's not the only place you could do it. You could bring like the program module to your VM. You could add different host functions, maybe for like optimized interactions. So just to clarify some of the terminology here, we would expect maybe someone to run like a long-lived ProgramVM, similar to like how you run an EVM. But we expect also people to augment like what are more focused virtual machines with like program execution capabilities, maybe as more of an add-on rather than the core thing. But I think just to be clear about what this looks like. Yeah, sorry. Go ahead.
Go ahead, Matthias.
Yeah, thank you. Like the final question is what's missing, right? And I mean, it's a very difficult thing to solve, and it comes with a lot of complication technically, but it's events. And what I'm missing when developing smart contracts or any kind of D app, especially on EVM networks, it's kind of an event mechanism. you're basically you're relying on keeper mechanisms or whatever in order to execute something based on something external or an external dependency. And like I said, like this is something that's huge to solve. Will have, I think, big ramifications, but of course, it's a big technical challenge in order to actually achieve it. But yeah, if you're asking what's missing, I think that's it for me personally.
Noted. I have my hand up, so I guess I can go. Just wanted to add to the previous topic, like what Patrick was explaining. Like I was not as much, I think, targeting, the interfaces as more of like some need of like standardization, like in whatever format it happens, especially when taken into account, with the teleporter integration and cross-chain communication. I think a lot of use cases will probably be people will still have some of their tokens or need to use the C chain for different reasons, like liquidity, centralized exchanges, and so on. So standardized way of like to understand what is the destination token type on HyperVM to do that teleporter messaging and bridging is basically, I think, what's probably important.
Yeah, the one thing I noted when we talked about this and was to like actually trace like even the full interaction of ETH across like smart contracts. You have to run debug trace. Like that's the only way to understand all the different places ETH flows. I would hope that we can do better than that, but in the nihilistic case where you don't do any of this tracking, like it definitely begs a question of like whether or not, or like how much support you can provide in that case outside of just state diffs. So it's a good question.
Tal, I think you had your hand up.
Yeah. So I have a little experience testing with Cosmosm, and I found that it's super easy to test. I think from a developer's perspective, the programs you write need to be easy to test, and that's pretty much the only defining feature that I think should be important in the programs module. So I was just wondering if all the programs that you're running right now, can they be run inside the simulator? And is that the testing environment? And it's just being called a simulator?
Yeah, so right now, that's kind of the only way to test things. And right now you can actually run your tests just like any regular REST test. Like we've been writing tests in the lib.rs file, which is your quote unquote contract or program file, and just writing like a test plan where you can create keys and everything. I know it's a little different than the way Cosmosm does it, but we're hoping to kind of get as like as little deviation as possible from like a Web 2 testing flow, if that makes sense.
Yeah, thanks.
Cool. I think we can move on here, Jacob. But if anybody wants to reach out or anything, has questions or has ideas, like always feel free to open a discussion on GitHub and just mention me, Richard Pringle, all one word. I'm also in the Telegram group or whatever. Happy to discuss anytime.
Sweet. Thanks, Richard. Next, we've had a community member working on some really interesting ZK proving in the HyperSDK. So Manoj, if you want to go ahead and take the floor.
Hey guys. Actually, we are working on making a verification layer on HyperSDK. Actually, we are working on making a verification layer over the top of HyperSDK. We have figured out how can we communicate with the proving and verification modules which are written in the Rust. So actually, what we are doing is my audio clear? Okay. So actually, What we are doing is for any verification system which is written in Rust, we are spinning up a server, a Rust server, and we are trying to communicate with the server with the proofs and getting the verification result through the server. And we have increased the block time for around 15 seconds. And till now, we have tested with SP1, Midden, and RISC-0 VMs, and they are working good. But we are facing a few problems over it. One of the thing is chunk with the introduction of the chunk keys at the end of the any state key which we prepare, the state storage which we are getting for particular key is limited to 4 MB, I guess. So for some of the proofs, the proof size may be too big. So we need to allocate in multiple state keys, but I guess that can be easily figured out, I guess. Also, as there should be an automatic state pruning thing which we need to also incorporate in our design, because if there are more number of proof verifications happening, there would be a lot of state accumulation. Let's say for the simple math which we are doing, we're assuming around 1.5 to 2 seconds for proof verification, and let's say proof is of the size of 2 MB, and we are allowing for the proofs to be verified in the first 10 seconds of a block. So, and maybe for 2 cores of the transaction execution, we'll be having around 10 transactions. So for a particular block, we'll be having 10 proof verification transactions, and it would be around 20 MB. And for a minute, it is around, I guess, 40 MB. So it would hit a 1 GB of the state very sooner. So we don't want to face a very critical issue over that. So we want to design something like the state after a particular time would be cleared out if the interactions haven't been made with the state case. So that is also one thing which is in our plans.
Yeah, one thing to note there on the 2 megabyte size you mentioned. So the network message size limit right now on Avalanche Go is limited to 2 megabytes.
Yeah.
I think it's like just over 2 megabytes.
Yeah.
To do what you want to do, like having multiple 2 megabyte proofs, like I would recommend using hashes more so than anything else, rather than like the actual blobs themselves in the blocks and in the state. So like if you want to take a look at an example database you could use that would be good at this, check out the FileDB in the Vryx branch. It's built specifically for this, which is like, because like if you put more than a few, like even a couple hundred kilobytes inside of Pebble or State, like it just not great for that, like not built for that. And so this lets you like much more easily keep track of where everything is. And then if you store the content by hash, I think inside of this like FileDB, you can then track very easily what's in the database, distribute it kind of using some other more sophisticated like broadcast tree, not in the block itself. And then prune it outside of the block without actually pruning the blocks. So you can keep like the verification history, aka like the hashes of the proofs in the block and in state, but then remove like the actual distribution of the proofs from this layer. And like you can use just P2P for that, plus use the FileDB. I think that would be a better. I'm going to mute you for a second because I'm getting some echo, but I think that would be a better way to distribute that amount of data through the network. One like area that I wanted to focus on at some point and like write an SDK for is this like general data distribution layer, which uses like something like a broadcast tree over like the set of participants, so you can like efficiently distribute like some piece of data via gossip rather than just like a random all-to-all style thing. So if anyone's interested in building that like broadcast style tree, that'd be super cool. Yeah, usually that's paired with like some form of erasure coding so that you can tolerate some failure of the broadcast tree and still get the chunks you need. But yeah, that would be a very cool addition. So you could like efficiently distribute some form of data throughout the network without having everyone do it. But yeah.
You might be able to modify or look at Solana's Turbine to get, I know they're doing a lot of stuff around erasure coding and having the tree to distribute data for blocks. I know it's a different use case, but you may be able to look at that just for general design and how they've thought about it.
Yeah, there's like a great Helios blog, I think, about how that one works. That would be an example, I think, of this mechanism. I'm not sure it's exactly what we'd want because I think there's some other things that it does, but that would be a really good example of like a BFT resistant broadcast tree or like a BFT hopefully tolerable broadcast tree. I think in Vryx we've taken more of the pessimistic, robust view, which is to say, like, if you want a chunk in the blocks, you got to send it to people because everyone else is sending their own blocks. So don't expect to rely on the bandwidth that other nodes are willing to give you pro bono.
All right. And the other thing, maybe it's a type of feature request you may consider. Actually, if for the context, there would be few types of transactions, and one of the key transaction or action type would be verify action. So this needs around 1 to 2 seconds of time, and the max timeout for the verify would be 5 seconds. So we don't want this type of actions to be included at the end of the block. So if they are included at the end of the block, so during the execution, it may take a lot of time, or it may hit into some other different error. So we want that type of actions to be limited till a particular time in the block.
So this is, I think, something that will make a lot more sense in the Vryx world, like, and less sense in the pre-Vryx world. So like in the pre-Vryx world, like verification happens during consensus. Like when it's verified, like the block is verified, it verifies all the transactions. In Vryx, that happens like asynchronously, and you have a configurable depth at which you're needed to post the execution results. So you can have like if you expect blocks to take a long time to verify or like, whatever, you can just set that execution depth to be longer, and then you can like fan out the proof verification. I would say like what you've described is interesting. I don't think it actually is going to work that well on the pre-HyperSDK design because of all these like latency requirements, but I think it's going to work really well on the Vryx style with this like async execution queue. Like it fits much better with this verification stuff as long as, yeah. So I think that, and it's also like much easier to parallelize. Like it's much better for like a high throughput application. Like if you're willing to accept like a little higher, yeah. I just think like this async execution engine is going to be much better for this use case. So I would say like, what you're doing of like fanning out the proofs to like other machines, I think you said, or if you just want to use it on the same machine, nonetheless. But like that long of verification time during consensus is going to cause issues because like polls will not be processed while you're verifying these proofs. So yeah, it should be interesting. I'm not sure it's the right. Like you should obviously keep trying to make it work, but I think it'll become a lot easier to make it work in the Vryx style. I don't know if that made sense.
Yeah. Also, maybe for the rules defined, maybe there is a fetch custom rule which gives a ease to define our own custom rules, but it can be eased out for better usability. I mean, it puts in a situation to define all the custom rules as an object and doing things over it. So, but if fetch custom actions could be much flexible, like we can go on and add whatever we want on the straight Genesis component, I guess. I mean, the Genesis interface where all the rules are being defined on, I guess. I'm not sure. So that would be a lot easier, I guess.
Instead of the registry, or what do you mean?
Chain dot rules. I'm speaking about chain dot rules.
Oh yeah. So that's the goal for some of those rules. Is that so? Right now, like I customize some of those rules. You can see in some VMs, like either the Morpheus VM or Token VM, where I add additional fields to Genesis and then and pull those into the rules as like the base mechanism. But there isn't a great I would say like the rules thing has an interface I like, but not necessarily the mechanism I like. So like in terms of how rules get updated or are managed, I think like the reason for that is that I really wanted to add a. Have you? I don't know if you're familiar with this concept we've talked about a few times called the self-signed warp message. It's basically the subnet signs a warp message to itself. And
Oh, yeah,
so,
sorry.
yeah. And so that message could have rule or config updates in it so that you could change rules on the fly if like a super majority of stake said like we should update this rule. And then as soon as it was processed by the chain, it would just cause that rule to update. So my thinking more so is like that the rules itself will transition from away from the Genesis thing and instead be moved into a like state directly, because then this will allow you to quickly update rules and then track the rules. And then all of the rules would basically be keys inside of state that will be accessed. And so in that world, like then there'll just be this array in the Genesis file where you can just populate all of the rules that you want to set on Genesis. There'll be some like verifier that after Genesis is processed, you ensure all the rules are set at some level, and then they can be modified via these like self-signed warp messages over state. And so that would, I think, give you what you need. But that's how I've thought about it so far. It hasn't been on the top of my list to focus on. But I think that is the mechanism that would be most useful based on what we've learned in other things, because this could allow you to basically disable certain actions, enable certain actions, change the fees, change gas targets, change all of that stuff, which would be pretty cool.
Yeah. That's all from my side.
Sweet. Thank you for sharing. If anyone else has any like general questions or comments, feel free to go ahead.
Yeah, I think self-signed warp messages will be used for a lot of things in the end, especially for stuff around CK AWM as well, because you effectively are able to make a light client with it. If you have it with a state root, you're able to basically use it as a light client. And we're exploring stuff on that side as well. So that's why I said we use it, because that's the exact way we're using it right now, except instead of rules, we're using state roots and Merkle trees of validators. So that's how we're seeing it. And it's working quite well. It's actually quite simple. I think it's going to be a great way to kind of make a light client, maybe on not the most, like, obviously light clients are kind of on a spectrum right now where it's like full storage proofs or just BLS verification plus validator verification. So it's kind of a beginner version. It's a lighter light client, but that's how we're thinking about it right now.
Yeah, I think that's some of the same ideas with this like subnet orchestrated validator sets as well. So I think the hope is that the consensus engine will soon be able to like just emit these sort of things outside of having to do it yourself. But like I think that primitive is super great. The only issue, so we use multi-signature BLS pretty heavily, as most people that are familiar with what like the crypto we're using here is. One huge benefit of using threshold BLS is that if a subnet had a key, like a stable threshold key, and you knew it, and then the subnet itself handled like rekeying in the case of like validator set rotations, you wouldn't have to track the P chain at all. And you could just know that like any message signed from this key, assuming that the subnet wasn't compromised, would be a valid root update. So if you hard coded like one BLS public key, you could know with confidence that a light proof is correct. In the multi-signature world, you need to understand like who the signers are supposed to be, which just makes it a little more complicated to seed the light client and then keep it updated. So that's one thing I've seen some other networks do that would be like, technically speaking, is pretty cool. The only issue with threshold BLS, there's a few things you have to kind of do right with threshold BLS, which makes it more complicated, but I think it's pretty cool. I think this would also be easier for like clienting if you like had some form of like epoching or like less frequent validator set updates. All of those are kind of things that we've discussed in this ACP.
What's the general kind of, I know that we're moving to pay as you go. I believe that's been voted on. I know that's kind of planned out at some point. Is the subnet orchestrated validator sets going to happen at roughly the same time, or how's that kind of all fitting in?
I think of it all as like one big related pie of like all the different things here, really trying to just target like what is the optimal relationship between subnets and the primary network. Because if we are able to move like all this orchestration off chain or like onto subnets and then just rely on like BLS signature verification and some like minor state updates on the primary network, we can probably get to like this like ideal solution much faster than we would otherwise, I guess. If we don't do this and then we try to like add more logic for staking on the P chain, it's just going to take a lot longer, in my opinion.
That makes sense, as well as it makes it more scalable for like not having to rely on the P chain. So makes it
Yeah, in
so
this case, I think like the issue we
whatever
see
they
is
want.
like if there's like some primary network issue, like we don't want the subnets to stop. We want the subnets to just have delayed view of information. And using like this sort of like async coupling, that is what would happen. So I think that's the direction that we've at least lately been pretty excited about. But there are like a lot of benefits to doing it outside of that, which is you get these like state roots that are assigned by the participants of the network. You get all sorts of cool things that you can use for other applications. Yeah.
Sweet. Sounds good. Thanks for everyone for joining. See you next time.
See you guys. Thanks.
Bye-bye.